Hello, my dear students. Welcome to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 2, Random Variable and Discrete Probability Distribution, brought to you by Vitan Sir. This time around, I am not going to do all the illustrations, but I'm going to select some of the remaining illustrations of this chapter and explain them to you based on the importance and how many times they have been repeated in the exams and all that. So I may have omitted some of the illustrations out of the remaining illustrations. Illustration 16. The parameters of a binomial random variable x are n is equal to 4 and p is equal to 1 upon 3. We have to state the probability distribution of x in a tabular form and find the value of probability x is less than equal to 2. Now, how we are going to start that because p is given, we can start by calculating q, that is 1 minus p, that is 2 upon 3. And next, because n is given as 4, we can see that x would be 0, 1, 2, 3 and 4. Okay, so px is ncx, p raised to x, q raised to n minus x. We have to take this for each and every value of x, that is 0, 1, 2, 3 and 4. So p0 will be 4c0, 1 upon 3 raised to 0, 2 upon 3 raised to 4 minus 0. That would be 1 into 1 into 1 into 16 upon 81, and your answer will be 16 upon 81. When I take it as 1, it will be 4 into 1 upon 3 into 8 upon 27 and 32 upon 81. Similarly, when I take it as 2, it is 4c2, 1 upon 3 raised to 2, 2 upon 3 raised to 4 minus 2, that is 6 into 1 upon 9 into 4 upon 9, that is 24 upon 81. And then when I take it as 3, 4c3, 1 upon 3 raised to 3, 2 upon 3 raised to 4 minus 3, that is 4 into 1 upon 27 into 2 upon 3, that is 8 upon 81. And finally, p4 is 4c4, 1 upon 3 raised to 4, 2 upon 3 raised to 4 minus 4, that is 1 into 1 upon 81 into 1, that is 1 upon 81. So let's depict this data in a table. So in the table it will be x and px. So x is 0, 1, 2, 3, 4 and total. Px is just writing the data which we have just calculated here: 16 upon 81, 32 upon 81, 24 upon 81, 8 upon 81 and 1 upon 81. Final 81 upon 81, that is 1. Next we have to calculate the value of px less than equal to 2. So when I am talking about x which is 2 or less, we have 0, 1 and 2, 3 values. So p0 or 1 or 2. Now p0 is 16 upon 81, 1 is 32 upon 81 and 2 is 24 upon 81. So when I just add them up, I get 72 upon 81. And when I simplify it, I get 8 upon 9. Okay, so the answer for this illustration is 8 upon 9. Moving on to the next one. Illustration number 17. In a binomial distribution, for x, n is 8, 2p4 is equal to 5p3, and we have to find the probability of getting success in all the trials in this distribution. Now, first of all, as you can see, only n is given and then 2p4 is 5p3. The relationship is given between them. So we are going to use this relationship and calculate the value of success, and that way we can calculate the probability of getting success in all the trials in the distribution. Now when we put n is equal to 8 in our regular formula of px, we get 8cx, p raised to x, q raised to 8 minus x. Now we know that 2p4 is 5p3, so that just means that 2 into 8, 4, p4 means x is 4, so 2 into 8 c4, p raised to 4, q raised to 8 minus 4, that would be 5 into 8c3, p raised to 3, q raised to 8 minus 3. When I simplify it, I get 8c4 is 70, so 2 into 70 plus p raised to 4 will be p raised to 4 and q raised to 8 minus 4 will be 4, equal to 5. 8c3 is 56, so 5 into 56 into p raised to 3 will be p raised to 3 and q raised to 8 minus 3 is q raised to 5. Now what I'm going to do is I'm going to start cancelling the values. Now on the left hand side I have p raised to 4 and on the right hand side I have p raised to 3. So when we cancel them with each other, we are left with a single p on the left side. Similarly, on the left side we have q raised to 4 and on the right side we have q raised to 5. So when we cancel them with each other, we are left with a single q on the right side. So 2 into 70, 140 into P equal to 5 into 56, 280 into Q. So I'm going to change the side of 140. So P is equal to 280 upon 140 Q, that is 2Q. Now we know that Q is 1 minus P. So 2 into 1 minus P will be 2 minus 2P. And when I change the side of 2P on the left, it becomes P plus 2P, 3P is equal to 2. And when again I change the side of 3, it becomes P is equal to 2 upon 3. So value of probability of success is 2 upon 3. So that way the value of failure will be 1 minus 2 upon 3, 1 upon 3. Now I have to find the probability of getting success in all the trials. Getting success in all the trials means x is equal to 8. That means if total number of trials are 8, x will also be 8. So when I put this 8 value in my equation here, 8c8 into p raised to 8 into q raised to 8 minus 8. 8c8 is 1, p is 2 upon 3 raised to 8 and q is 1 upon 3 raised to 8 minus 8. So when simplifying, I get 1 into 256 upon 6561 into 1, and the final answer is 256 upon 6561. So the probability of getting success in all the trials for this distribution is 256 divided by 6561, and there is not an option for simplification here. Okay, so this is the final answer. Illustration 18. For a binomial distribution, mean is 18 and variance is 4.5. We have to determine the skewness of this distribution. Now, if you remember correctly the characteristics of the binomial distribution, you will remember that when p is less than 1 upon 2, the skewness is positive. When p is more than 1 upon 2, the skewness is negative. And when p is equal to 1 upon 2, there is a zero skewness, there is a symmetry. So we have to calculate the value of p and then compare it with 1 upon 2. So we have the mean and the variance. So mean is variance is actually npq and mean is np, and we know that q is variance upon mean, that is npq upon np, that is 4.5 upon 18, that is 1 upon 4. So if we know q, we can calculate p, that is 1 minus q, that is 1 minus 1 upon 4, 3 upon 4. Now we know that 3 upon 4 is greater than 1 upon 2. That means p is greater than 1 upon 2. And from the characteristic of the binomial distribution, when p is greater than 2, the distribution has a negative skewness. So the skewness of distribution is negative. This is kind of a 2 marks question asked in the board exams many times. So remember that. Now I'm going to skip two illustrations, that is 19 and 20, and move forward towards illustration 21. An experiment is conducted to toss 5 balanced coins simultaneously. Okay, we have 5 coins. The event of getting H is considered success. Okay, so success is heads, failure is tails. Obtain the probability distribution of the success. If this experiment is repeated for 3200 times, then obtain the expected frequency distribution. Also obtain expected value of number of successes and its standard deviation. Now this is a pretty big question. We have to obtain the probability distribution, that means we have to obtain the formula for that probability distribution, then we have to obtain the expected frequency, expected value of number of successes, that is mean, and the standard deviation. Okay, now let's start here. Because we need H as a success, so probability of getting H is the P. Now of course, because it's a coin, H has the probability of 1 upon 2. Similarly, the failure Q is also 1 upon 2, and we know that number of times a coin is tossed, or 5 coins are tossed, so small n is 5, while this experiment has been repeated for 3200 times, so capital N is 3200. So when we are calculating the probability, we need the small n, but when we are calculating the expected frequency, we need the capital N. We will see how we do that. Next, px is ncx, p raised to x, q raised to n minus x. Now n is 5. Probability of success is 1 upon 2. Probability of failure is also 1 upon 2. So let's just put it there. 5cx, 1 upon 2 raised to x, 1 upon 2 raised to 5 minus x. Now because the base is same, 1 upon 2 and 1 upon 2, when we multiply the values, their power will be added. So 5 minus x plus x will be 5cx, 1 upon 2 raised to 5 minus x plus x. So that is 5cx, 1 upon 2 raised to 5. Getting my point here? 1 upon 2 raised to 5, that is 1 upon 32. So 5cx into 1 upon 32, that is 5cx upon 32. So the probability distribution here is 5cx upon 32. So if I take x is equal to 0, then 5c 0 upon 32. If I take x is equal to 1, then 5c 1 upon 32, and so on. Values will be there. So let's just write down the values here. Okay, and next, if I take 5c 0 upon 32 will be 1 upon 32. If I take 5c1, then 5 upon 32. If I take 5c2, then 10 upon 32. If I take 5c3, then again 10 upon 32. That means I have just simplified my whole equation here. That means I am not going to use the complete equation, rather I am going to use the simplified format of that equation to calculate it faster. It is not always possible to simplify it, because this is a probability of coins, and because the success and failure always have the same probability, we are able to do this thing here. Okay, so 5c4 upon 32 is 5 upon 32, and then again 1 upon 32. Total is 1. So now this is the probability distribution of the successes. Next, I have to calculate the expected frequency. That would be capital N into the probability of success. For example, if I need to calculate the frequency for 0, then I just multiply my probability 1 upon 32 with 3200, and my answer will be 100. So the frequency, if I am repeating this experiment for 3200 times, so the number of times I get 0 heads is 100. Similarly, 5 upon 32 into 3200 is 500. So number of times I get 1 head is 500. And similarly, I will get all the remaining answers here. Just multiply probability with the capital N, and you will get your expected frequencies. Now I have to calculate the expected value of success. That means NP. Okay, the expected value of success is NP. NP is N into P. N is 5. P is 1 upon 2. 5 upon 2, that is 2.5. Similarly, the standard deviation of the successes, that is root NPQ, that is 5 into 1 upon 2 into 1 upon 2 root, that is 5 upon 4 root, that is 1.25 root. The answer is 1.118. So the expected value of successes, that is the mean, is 2.5, and the standard deviation of the successes, that is NPQ root, that is 1.118. Now I don't think illustration 22 is that much important, and so I will end my current tutorial here. Next time I will be ending this chapter by solving the exercise, the final exercise, I mean the exercise 4. The exercise 2.2 for this chapter, because there are only 2 exercises and this chapter is very small. In my next tutorial I will end the chapter. If you have liked my video, please put your suggestions and comments, like my video, subscribe my channel, and share it with your friends, and I will see you in my next tutorial. See you then. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan Vora, and I teach accountancy, statistics, and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel, and also check out my other video playlist which you can see on the screen. Thank you, and I will see you in the next video.